Power and Exponent. In this module, you will learn about the introduction to powers and exponents and laws of exponents. Let us understand the meaning of powers and exponent. A power is the product of multiplying a number with itself. Usually, a power is represented with a base number and an exponent. The base number tells what number is being multiplied. The exponent, a small number written above and to the right of the base number, tells how many times the base number is being multiplied. For example, 6 to the 5th power may be written as, here the base number is 6 and the exponent is 5. This means that 6 is being multiplied by itself 5 times. Let us see more examples in the given table. Let us see some more examples. Write the following numbers in powers of 5. First, 125. Second, 625. Solution. 125 is equal to 5 multiplied by 5. Multiplied by 5 is equal to 5 raised to power of 3. And 625 is equal to 5 multiplied by 5 multiplied by 5 multiplied by 5, which is equal to 5 raised to power of 4. Now, let's learn laws of exponent. First, product rule or multiplication rule. Product rule with same base. For any positive integers m and n, and for any real number a raised to power m multiplied by a raised to power n is equal to a raised to power m plus n. For example, x raised to 4 multiplied by x raised to 3 is equal to x raised to 4 plus 3 equals to x raised to 7. And 2 raised to 3 multiplied by 2 raised to 4 gives 2 raised to 3 plus 4 equals to 2 raised to 7 equal 2 multiplies by 2 7 times equals 128. Product rule with same exponent. For any positive integer n and for any real number a and b, a raised to power n multiplied by b raised to power n is equal to a multiplied by b raised to power n. Example: x raised to 4 multiplied by y raised to 4 is equal to x into y whole raised to 4. That gives xy raised to 4. And 3 raised to 2 multiplied by 4 raised to 2 is equal to 3 multiplied by 4 raised to 2, which gives 12 raised to 2. Therefore, 12 into 12 is equal to 144. Second quotient rule or division rule. Quotient rule with same base. For any positive integers m and n, and for non-zero real number a, 3 cases exist. Case 1, if m is greater than n, then a raised to power m divided by a raised to power n is equal to a raised to power m minus n. Example: 7 raised to power 5 divided by 7 raised to power 3 is equal to 7 raised to power 5 minus 3, which would be 7 raised to power 2. Case 2. If m is less than n, then a raised to power m divided by a raised to power n is equal to 1 upon a raised to power n minus m. This is also known as law of reciprocal. Example: 2 raised to power 2 divided by 2 raised to power 4 is equal to 1 upon 2 raised to 4 minus 2, which would be 1 upon 2 raised to power 2. Case 3. If m is equal to n, then a raised to power m divided by a raised to power n is equal to 1. This is also known as law of a number with 0 exponents. Example: 9 raised to power 7 divided by 9 raised to power 7 is equal to 9 raised to power 7 minus 7, which will be 9 raised to power 0, that is equals to 1. Quotient rule with same exponent. For positive integers a, m, and n, and for non-zero real number b. If m equals to n, then a raised to m divided by b raised to n is equal to a raised to m by b raised to m, that is, a by b raised to m. Example: 6 raised to 7 divided by 3 raised to 7 equals to 6 divided by 3 whole raised to 7 equals 2 raised to 7 equals 128. Now we will study third law of exponent, that is, power rule. Power rule 1. For any integers m and n, an integer or fraction number a raised to the power m whole raised to the power n is equal to a raised to the power m multiplied by n, or a raised to the power mn. Example: 3 raised to the power 2 whole raised to the power 3 is equal to 3 raised to power 2 multiplied by 3, which would be 3 raised to power 6. Power rule 2. For any integers m and n, an integer or fraction number a raised to power of m and m raised to power of n is equal to a to the power of m raised to n. That is, first calculate m raised to n, then a raised to their answer. Example: 2 raised to 3 raised to 2 equals 2 raised 9 equals to 512. Last rule of laws of exponent is negative exponent rule. For any non-zero integers or fraction a and non-zero integer n, a raised to minus n is equal to 1 upon a raised to n. Example: 2 raised to minus 3 is equal to 1 upon 2 raised to 3 equals 1 upon 8 equals 0.125. Let us revise all that we learned in this module on power and exponent.